So this is section 1.1, undefined terms and first definitions. So we start off with a bunch of definitions here. So the first one, circularity, on page 28. The best way to think about circularity, it's kind of like, they kind of have a picture here, but it's kind of like if you look something up online. So say you're reading something and you don't know what a word is. So say you didn't know what ball was. Okay, so you look up ball on the internet and they tell you it's a sphere. Okay, well you don't know what a sphere is, so then you look up sphere on the internet and they tell you it's a ball. Well, you still don't know what a ball is. All they told you was it's a sphere, and then it took you right back to ball as your definition, and really you still have no idea what either of those words mean. That would be circularity, where you have like a definition and then it just keeps, going back to a bunch of words that you don't know. So they kind of show something here, what could be circularity. So say we looked up the word exact location. Well, when we looked up the word exact location, we got point. Well, say we didn't know what that was. So then we looked that up. They gave us spot. We didn't know what that was. They gave us place. Then place took us back to exact location. And then so we just kept circling and circling and circling, and we still had no idea what that meant. Okay, that's what circularity means. Okay, so when we do definitions in geometry, we want to try to prevent that. Okay, one way we can use, or one thing we can do to avoid having circularity in definition is to use undefined terms. Okay, so undefined terms in like real life would be like the. So we don't have a definition for the word the, right? But we use it in definitions to help us explain things. Same thing with like the word is. There's no real definition of the word is, but we use it all the time to kind of help us with sentences and help us with definitions. So our three undefined terms in geometry are point, line, and plane. Okay, point, line, and plane are the undefined terms for geometry. Okay, so make sure you've got that written in there. Next definition is figure. So figure is a set of points. Okay, so they're using the word points, so we don't have to define that because that's one of our undefined words. So when we're talking about a figure, it's a set of points. So typically they'll say, in a book, they'll say like see figure 1.2 or something like that. Basically just means a picture. Okay, so a figure is just a picture of something, but the geometry definition of it is a set of points. The next one is space. Space is a set of all points. So basically, if you think about a room being filled with a whole bunch of points, just kind of scattered everywhere, in the sky, on the tables, on the ground, everywhere, that would be space. Okay? It's kind of hard to visualize some of these things because they're not something you can kind of like put a physical thing on. Next one is collinear. So what collinear means is it means three or more points are collinear if there is a line that contains all of them. Okay, so I'll draw something that's collinear here. So I've got a point there, a point there, and a point there. And if I connected those would all make a straight line. Okay, so those 3 points right there are collinear because they're all on the same line. Linear kind of sounds like line, so collinear is when they're all on the same line. Okay, so that's collinear. Plane figure. So a plane figure is a set of points that are all in one plane. Okay, so what a plane is, it's one of the words that we're not defining, but what it kind of is it's like a big surface. So if you think about a plane as like a tabletop, it's just like a flat surface that extends in all directions. It's kind of hard to describe, but just a big flat surface that extends in all directions. And it could be going this way. So you could have a plane that's like straight up and down. You could have it this way. Either way, that would be a plane. It could be crooked like this. It could be crooked like this, like this. Those would all be flat, big flat surfaces that extend forever. So a plane figure is basically something that would be all on that same flat surface. So like if this piece of paper was our plane, this picture here of the rectangle would be a plane figure because it's all entirely on that plane. Okay. Next one is coplanar. So dealing with the plane again, it says 4 or more points are coplanar if there is a plane that contains all of them. Okay, so I'm going to sketch a picture here. So imagine this as kind of a flat surface or a plane. So coplanar would be 4 or more points all on that same flat surface. Okay, so if I've got a piece of paper, they're all on that. Or if I had, like if I had this box here, a plane could be this top half of this box. So if I had 4 points on the top of this box, they would all be coplanar. Okay. Okay, next thing, for example 1, they want us to look at the picture that's on page 29 of the steps, and they want us to answer some questions. Okay, so I'll put the picture up here. Hopefully I can get it under here. Okay, so that's our picture right here. So the first one says, one set of 3 collinear points is A, E, and I. Okay, so this is some steps at a school or whatever it is. So they say A, E, and I are collinear because they're all on the front edge of that step there. What they want us to do is they want us to name another set, actually 2 more sets, of points that would also be collinear. Okay, so we want them to be on a straight line. So like if we took a ruler or something and lined it up with it, they would all make a straight line. So their example was A, E, and I. So another example would be maybe if you do the one that's right here, kind of at the back of that step. So B, F, and J, that could be another set. So B, F, J could be a set. And then another set could be C, G, and K, because those would all be on the front of kind of that middle step there. So C, G, and K, and the order for those doesn't matter. And then we don't need a third one, but a third one could be D, H, and L. All of those points would also be collinear. Okay, so they're all following along that straight line there. Now I wouldn't say like L, K, and I are, because you're jumping like through that step, because you've got a flat surface here, then you're going down, so that wouldn't make a straight line. Okay, so those would be 3 options there you could use for that. Okay, next one, they want one set of, or they say one set of 4 coplanar points is A, E, F, and B. So kind of a flat surface on the top of that step there. Name 2 other sets. Okay, so with this one, when you're thinking about your planes, you're either thinking about the top part of the step, like that being a plane, or the up and down the front part of the step being a plane. Okay, so if we're going to name 2 other sets, maybe we name like B, C, G, and F, because those would all be on the front part of that step if we were looking at in a 3D view. So we could go, what did I say, B, oops, imagine that's a comma, B, C, G, and F. Okay, those would all be on the front part of that step there. Okay, another option we could have, maybe we're still on that same set and we just name different ones there. So maybe we name K, G, J, and F, because those would all still be on the same flat surface. So K, G, J, F, that could be a set. You could do something on this top step here, so the flat part of the top step, maybe you went C, D, maybe went all the way over to L and K. That would also be one. Okay, so there's a lot of different combinations there, but it's basically just a flat level surface that you're looking at for coplanar. Okay, so get that out of there. Our next thing is 1-dimensional, 2-dimensional, and 3-dimensional. So the definitions are in your book if you want to check those out on page 29. I'll kind of write in what I think the definitions are kind of like, because the book ones aren't necessarily the best. But what it says for 1-dimensional, it says all points are collinear, so all points are in a straight line. And I'll put that too, all points make a line. Okay, so collinear, all your points make a straight line. Okay, slide it over so you can see it a little better. Okay, 2-dimensional, all points are, or let me say that again, all points are not all collinear, but are coplanar. Okay, so the points don't all have to be on the same line, but they do all have to be on the same flat surface. Okay, and we'll talk a little bit more about that in a little bit. So all points are not all collinear, but are coplanar. So all of the points aren't on just a straight line, like if I had a ruler, they don't all have to be on a straight line, but they do have to be all on the same flat surface. Okay, and then three-dimensional is all points do not lie in a single plane. So all points do not lie in a single plane. Okay, so that would be like kind of like a box like this. Okay, so you'd have a flat surface plane for the top, then maybe like a ½ inch down you'd have another flat surface and another flat surface, and you could just cut on an unlimited amount of flat surfaces through there, cut them into slices, and those would all be planes. You could cut a plane this way, you could cut a plane this way, you could cut a bunch of different planes, okay? So that would be something that's three-dimensional. Okay, so these next ones, they want us to classify these as one-dimensional, two-dimensional, or three-dimensional. Okay, so this first one here is just a picture of a rectangle. So a picture of a rectangle or a picture of anything that's on a flat surface is going to be two-dimensional. Okay, so this one here would be 2D. Okay, B of this is a straight line. Okay, the W is just naming the line. So that's all in one straight line. So I would match that with all points are collinear in a straight line. I would match that with one-dimensional. Okay, and then for C, that's supposed to be like a cylinder or like a soup can shape. So if it's something that has more shape than just like a flat surface, you could cut it into a bunch of planes or a bunch of flat surfaces if you wanted to. Like if you think about it as a cake, and maybe you split like a level of the cake there, level of the cake there, level of the cake there, and so on, that would be a bunch of different planes. That would be 3D, okay, three-dimensional. Okay, so just be careful with those. Those can be kind of tricky sometimes, but follow these rules when you're trying to figure out what it is. Okay, so that's it for the lesson. So what you have for your assignment is page 30, 1 to 11 all.